Hi, welcome to AT Math. Today, 11.4, linear, quadratic, and exponential models. Simply put, what's the difference between the three? Well, a linear equation, remember, is like a straight line. Now, it can go in any direction, but that is a linear equation. Quadratic, think horseshoe. And exponential, more like a quarter pipe, going up one side like this. So the linear here, straight line, or pretty much straight line. Quadratic, horseshoe. Exponential, coming up one side. Take a look. Linear, quadratic, exponential. Graphing data, choose a model. Graph each data. Which kind of model best describes the data? As you plug in the data, take a look. Clearly, it looks like exponential. Now, that's not to say for sure, because you would also, if you had more data, you'd want to do the other side to see whether it keeps going down or goes up. But with the data provided, looks like it's exponential. Graph each data set. What kind of model best describes the data? Looks here as you plug it in, straight line, therefore it's linear. Choose a pattern of model. Using patterns to choose a model. 0, 100, 200, 300, going up 100 each time. This one, 400, 256, 144, 64. Notice how you're subtracting. Now, no, there's nothing similar here. But if you do the second step, 144 to negative 122, negative 112, excuse me, negative 112 to negative 80, notice how you're adding 32 this time. Basically, because it's a two-tier or a second difference, you're looking at quadratic. And if you were to go ahead and graph it, you would kind of notice, you'd argue that it looks exponential, but because there's two tiers, it eventually will shoot up, and hopefully the other side. Take a look at this one here. You have plus 1, plus 1, plus 1. Notice how it's the first tier, there's the same. Basically, you have times 0.85 each time. Well, because it's a first tier change, but it's a multiply, not an add, it's going to be a exponential. Here's how you figure that one out. General forms of function, basically linear is y equals mx plus b, quadratic is y equals ax squared plus bx plus c, and exponential is y equals a b to the x power. Problem solving application. Use the data in the table to describe how the ladybug population has changed, and then write a function that models the data. Use your function to predict the ladybug population after 1 year. So, in 0 months, in the beginning, let's say you have 10 ladybugs. And in 1 month you have 30, 2 months you have 90, 3 months you have 270. Well, first we have to figure out what's happening. Well, I'm going up 1 month every time. That's kind of a given. Now, basically, if you try to do plus or minus, it ain't going to work because you're adding 20, adding 60, adding 180, right? So that's not going to work. When you multiply times 3 times 3 times 3, okay, that does. And so there you have that. Since it's multiplying on the first tier, it's going to be a exponential. So if you go ahead and there's a constant function, a constant ratio of 3, meaning you're times 3 every time, so it's exponential. So you're going to put 3 here to the x power. A is how much you started with. Y is how much you started with, which is 10, and A is going to be where you plug it in at. In other words, simply put, when you start with to the 0 power, it goes right here. So 3 to the 0 is 1. Excuse me. And what times 1 equals 10? And that would be 10. So we put 10 in there. So now you have 10 times 3 to the x power. Predict the ladybug population after 1 year. Well, how often are you're doing here per month? So it's per month. Well, there's 12 months in a year. Therefore, it's to the 12th power. So 3 to the 12th power. Take out my calculator here. It's going to be 531,441 times whatever you had. You had 10 to begin with, so times 10. You're going to have 5 million ladybugs. That's how you do it. And we are done. We'll do some more in class. Thanks again. Bye.